Hello, I'm Mr. Baldwin, and this is the Math Toolbox, where I teach you how to become a middle school math master. Today, we are looking at using the distributive property to expand linear expressions. So yesterday, we got into combining like terms, all right? And today, we're going to move into using the distributive property to be able to simplify our expressions. So we're just looking here to simplify expressions. So I want you to take this problem right here that you see, all right? And I want you, there's going to be a lot of examples here, a lot of student tries, all right, a lot of you tries. So when we get to each one of those, I'm not going to tell you every single time to pause it because that makes the video long and tedious. But whenever you see a new example, it's always a great idea to hit pause, all right, and try to do it yourself before you come back and see me do it, all right? Just a quick plug though, if you're here for middle school math, hit the subscribe button down below. What that's going to do for you is every time I post a video, you can click the bell as well. Every time I post a video, you're going to get a notification for that. And if you're stumbled onto my YouTube channel at the beginning of the year, or anytime in between, I'm sticking right with what just about everybody in the country is learning right now. So it's a great idea to click subscribe, hit the bell, so that you get that popped up. So if you didn't understand anything in school or you didn't understand the concept of school, you can come, and this is kind of a tutoring session, if you will. So again, we're back to this problem. Try it yourself, all right, and then come back to see what the answer is. All right, so we've got 3y plus 2y, 3y plus 2 plus 4y plus 9, all right? Yesterday I told you that if you will take these and if everything is addition, that's the first thing you want to do is make sure that every subtraction in the problem is turned to an addition problem by using keep, change, opposite. But once you're done with that, you want to try to reorganize this using the commutative property of addition that says that I can, if it's all addition, and I see all addition here between the terms, then I can commute the numbers. I can move them, all right? So I've got 3y plus, I'm going to put that 4y next to it because it has like terms. Then I've got the 2 and the 9 next to each other, and then I can combine like terms. If they have the same terms, like these two right here both have a term of y, all right, or a variable of y. If they have the same terms, you can add the coefficients and keep the term, all right? So 3y plus 4y equals 7y, and 2 plus 9, that equals 11. And that is as simple as you can make it. Do not make the mistake, all right, of going on and adding those together just like that. This is a common mistake. It's wrong, all right, because that 11 right there does not have a variable of y. And since we don't know what y equals, we can't do anything else to this over here, and we can't add that 11 to it, all right? Y could be any number, an infinite number of numbers, all right? And so right here, that 7, that doesn't really have a value. It has a function. It's being multiplied by y. Whereas that 11 over there, it doesn't have any variables next to it, so it's a constant, which means it does have a value. It doesn't have a function. It has a value of 11. So we're adding 11 to whatever y is times 7. So make sure that you don't make that unnecessary mistake by adding those together, all right? Let's go on to the next one, all right? We'll finish that one on out. You try this one. All right, if you tried this one, the first thing that you should do, and hopefully the first thing that you did, was turn every single one of those subtractions to an addition problem by taking this subtraction, all right, putting your finger on it, keep the number in front, it's the 7, the same, turn that subtraction to addition, all right, and then take that 3x, that next number, and turn it into its opposite. All right, so a 3x becomes a negative 3x. You're applying keep, change, opposite. Again, there's another subtraction right there. So we're going to keep what's in front. We're going to change the subtraction to addition, just like that. And then we're going to take 4 and make it its opposite, a negative 4. And then you can rearrange the problem, all right, to put all the x's near each other and all the constants near each other. In this case, you have 5x plus negative 3x plus 7 plus negative 4. Now, this is called the math toolbox, all right, because I, use some very specific tools, all right, and one tool that I love to use is called a tug line, all right, and whenever you're adding expressions like this or combining like terms in this expression, you can use a tug line like this. If you haven't seen the tug line before, you can go back to my video about adding and subtracting integers. I teach you how to use a tug line on that video. But here we are, we've got this problem right here where we're combining like terms, and I told you that I want to use a tug line on it, so this is how I'd use it, right? I'm going to make a tug line just for my x's, all right? So these right here have the same term. Those have x's, all right? I'm going to put that positive 5 on this side and that negative 3 on team negative, just like that. And then because you have team members on both teams, there's a war, all right? There's a battle, which means we're going to subtract these two numbers. 5 minus 3 is 2, and the bigger army was the positive, so that's a positive 2, all right? And we're going to keep our term x. Okay, so we titled our tug line x, so we'll keep that term x right here, and then we can move on to our constants. So I'm going to use a separate tug line just for the constants. There's a 7, there's a negative 4, subtract them, and because there's a war, and then keep the sign of the larger number, which is positive. That's a positive 3. So my final simplification of that expression is 2x plus 3. Now again, if you didn't understand what I'm doing with the tug line right here, don't worry about it. You can go back and watch that video, adding and subtracting integers, where I talk about the tug line. I'm just showing you, if you already use a tug line, you know how to use it, how it can be useful for combining like terms, all right? You can make separate tug lines for the different terms that you have, all right? That was a terms of x. This one was for our constants, all right? So two separate tug lines for the two separate terms. All right, let's try one more. Try that one. All right, and it might tell you at the very beginning, you might look at that and say, well, I see a y and I see a y squared. Can I combine those? Here's the definition of a like term, all right? Like terms are those terms that have the same variable with the same exponent, right? So right here, the y and the y squared does not have the same exponent, right? So first thing you need to do, pause the video and try it yourself, all right? But after you've done that, then the first thing you need to do is turn everything into an addition problem. All of these subtractions right here, or both of these subtractions, you need to turn to an addition problem by applying keep. We're going to keep the 4y, change the subtraction to addition, and then we're going to make the 6y squared into a negative 6y squared. Right? Then we've got this next subtraction. We're going to keep what's in front of it. Then we're going to change subtraction to addition, and we're going to take that 2y and make it a negative 2y. And then we have our plus 9y squared. And then we can rearrange this. We can put all the y's together and all the y squareds together. Now it looks like, because they have the same variable, these might be the same terms. But notice, this one right here, all right, the negative 6y squared, the y squared has an exponent, and the others over here, they don't, all right? So these two have the exponent of 2 on the y, and these over here do not have exponents, all right? And I also want you to notice that that exponent is on the variable, not on the number. Right? So it's y to the power of 2, not negative 6 to the power of 2 multiplied by y. So you've got y to the power of 2, which we don't know what y is, so we can't simplify that. We just have to represent it as the term that it is. All right? So now that we've grouped everything, 4 plus negative 2, that's a positive 2. And negative 6 plus positive 9, that's a positive 3. And we're done. We've got 2y plus 3y squared. All right? Well, that's the combining like terms. All right, that's kind of a recap from yesterday. Today, we're getting into learning distributive property, and specifically using distributive property to expand a linear expression. And then we're going to pull that information in and put it in a bigger expression to be able to combine like terms as well. All right, so we're at this point right here. Distributive property tells us that we can multiply a sum by multiplying each add-in separately and then adding the products together. All right, so here we have a 3 times x plus 6. All right, and we have to remember on this 3 times x plus 6, right, The multiplication, first of all, well, I guess first of all, there's multiplication here, and I should tell you where that's at. That multiplication is right here in the middle. It's invisible between the 3 and the parentheses. All right. In math, we like to make expressions look as short as possible, and so we find different things to be able to, like, it's not really a shortcut, but we kind of make it like a shortcut where we try to condense the expression as much as possible. And one way that we do that is we make multiplication invisible, all right? We make it the default operation. So if you see a number next to a variable just like this, that means multiplication. Or if you see a number next to a parentheses like that, all right, that means multiplication. So this right here is a really short way of writing 3 times 6, all right? And that's a really short way of writing 3 times x, right? So we try to condense it, make it a little bit shorter by taking the number that we want to multiply and then multiplying it by either a parentheses with the other number that we want to multiply on the inside, the other product, or right next to the variable, just like that. So this is multiplication, right? So right here, we have a 3 right next to a grouping, right next to a parentheses like that, which means we're multiplying that 3 times everything in the grouping. We have to be fair. We can't just multiply it by the x, and we can't just multiply it by the 6. It has to be multiplied by everything in the grouping, all right? So you have to distribute that multiplication fairly to everything, all right? So don't make the common mistake of just multiplying it by the first number, okay? So right here we've got 3 times x, and then we're going to have an addition sign, plus whatever 3 times 6 is, all right? Because the distributive property says it lets you multiply a sum, all right, which is the sum, all right, by a product, or it's not about a product, by a factor, all right, by multiplying each factor or each add-in separately, all right, and then adding those together. So it looks like this in expanded form, right? 3 times the x, we could write it like this, 3 times x plus 3 times 6, just like that. So we've expanded the multiplication to say we're multiplying that 3 times that x, and then we have the plus sign, all right, and then we are multiplying it 3 times the 6 right there. And then we can simplify it on down. 3 times x, that's just 3x. Keep our plus sign right there, and then 3 times 6, that's 18, right? So that is the correct answer using distributive property, okay? So 3 times x plus 6 simplifies to 3x plus 18, all right? Again, just watch the animations here. We're distributing that multiplication of 3 to everything in that parentheses, and then we can write it in expanded form, all right? This right here, writing in an expanded form is a step that's a great step to take when you're first starting out using the distributive property, all right? But it's also a step that in the future, you don't have to necessarily write it in an expanded form in order to get the right answer, so long as you remember that you're multiplying that 3 times that x and you're multiplying that 3 times that 6. But again, that's a really good first step if you're first starting out with this or you're struggling with it, all right? All right, I want you to try this one. So pause the video and then try this one. All right, you should have distributed and write the arrows. If you didn't write the arrows, go back and look at it and see if you got it right, all right? If you didn't get it right, then I would absolutely tell you, write the arrows, all right? Draw the arrows, 2 times that 3, 2 times that 6, and then you can put it in expanded form, all right, which looks like this. 2 times that x looks like 2 times x. Keep our plus sign, and then 2 times 3 looks like 2 times 3, and then we can simplify it on down. 2 times x is 2x's, and 2 times 3 is 6. And we add those together. So the final answer is 2x plus 6. All right? Why don't you try this one? I know there's decimals, but it's just a decimal. All right? It's just a decimal being multiplied by the variable and then multiplied by a constant right there. All right? Again, we take this and we distribute the multiplication of the 4.1 times the x and the 4.1 times the 5. Just like that, and then we can simplify it on down. 4.1 times x is 4.1x, and then 4.1 times 5 is 20.5. All right? Try this one. Now, on this one, just pause for a second. Don't pause the video, but just think about it for a second. All right? Let's give this a little bit of an example right here. Whenever you have a number All right, let's do this first. A number, all right, you have two like terms that are being added together, all right, and you have the coefficients that are attached to them, all right. You've got like a 3x plus a 4x. Whenever the operation is addition, you're taking the coefficients and you're just adding them together and keeping the variable, right? But whenever you have a number being multiplied by a variable with a coefficient, right, you're just multiplying the numbers that you see, all right, 3 times 4, that's 12, and then you're keeping the variable right there. And essentially what this is telling us is 4 n's. If I were to write them out, it would look like this. There's 4 n's. And I have 3 sets of 4 n's. So there's 2 sets, and there's 3 sets. That's what it would look like if I wrote it out. 4n is 1 line, but I have 3 lines of 4 n's, all right? And then I can count them all up. I have 12 n's just like that. So whenever you have a number being multiplied by a variable with a coefficient, multiply the numbers and keep the variable, all right? So with that in mind, go back to this other one that we were just about to try. So go ahead and pause this video and try it yourself, and then come back to see if you got it right. All right, so we're going to distribute that 3 times the 2/7 x and 3 times 5. All right, if I wrote it in expanded form, it would look like this. Okay, then I could turn this 3 into a fraction, 3 over 1, multiply it by that 2/7, which 3 times 2 would be 6, and 1 times 7 would be 6/7. All right, so 6/7 x, and then I've got that final, that 3 times that 5, that's going to be 15. All right, that's what the answer is. All right, try this next one. And you could turn that subtraction into an addition problem by doing keep, change, opposite. That's never a bad idea. Always a great idea, right? So you could do this, keep, change, opposite, or you can leave the subtraction in there and try that, all right? For this video, that's what I did, and I'll show you how we clean it up. So go ahead and pause this, try it yourself, come back and see what the answer is. All right, we're going to distribute that -4 times 2 and that -4 times y. And I'm going to write it in expanded form. Now, the reason why I did it this way and I didn't change it to addition right this second is because I wanted to show you that if we have subtraction on the inside and we decided to keep it as subtraction, then we need to have a subtraction between these add-ins right here, okay? All right, so you've got -4 times 2, that's the expanded form of that. And then you have the subtraction being kept from the inside of the parentheses. And now we have -4 times y. All right, and when we do that math, -4 times 2 is -8, and -4 times y is -y. So we have -8 minus -4y. And at this point, we want to clean this up, all right? I mentioned this the other day, but whenever you have a situation in an expression, like, let's just do like 2x minus -3, just like that, all right? Whenever you have at the very end, you've simplified your expression, you have this left over, either a minus negative or a plus negative, then you want to apply reverse keep change opposite, which would be, we're going to keep the number in front, 2x, change the subtraction to addition, and change the next number to its opposite, just like that. So 2x minus -3 is really 2x plus 3. So using that kind of thinking, right, then we could take this right here, we could turn that minus negative, we could do keep, change that to an addition, change that to its opposite. And so the final answer would be -8 plus +4y, right? All right, now let's take these and this distributive property, and let's embed it inside of a larger problem where you're going to have to combine like terms as well, all right? Now PEMDAS tells us, this is how I write PEMDAS, I always do keep change opposite at the beginning, best I can. Then we're going to look at our parentheses and then our exponents, then any multiplication or division from left to right, an addition or subtraction from left to right, and then you heard me a while ago say reverse keep change opposite. That's what we're doing at the end, all right? Which means we're turning any plus negatives or subtract negatives into subtraction problems, all right? We're cleaning that up a little bit, all right? Well, the problem that we just had, all right, that you can see over here in the bottom right of the screen, all right, just right down below me, all right, you can see that you've got this 4x plus 3 in the middle right here. If you go through this and you follow the order of operations, well, first of all, we don't have any subtractions to turn into addition. We look at our parentheses, and we can't simplify that because that's x plus 3. All right, so that's done. We can't do that. We don't have any exponents. We're all the way down to this third step right here. All right, this third step of PEMDAS, which is fourth in my process. But all right, this multiplication right here, we're all the way down here, which means we've got to address any multiplications that we see before we ever try to start combining like terms. All right, and the multiplication that I see is between this 4 and this grouping right here, this x plus 3. So I need to, in my margin, all right, I need to go and do that distributive property, do that math, where I distribute the multiplication of 4 times x and the 4 times that 3. So all I did down here is I took this middle part in, because I know I need to do this multiplication first, because order of operations tells me to do that, and I did this over in my margin, or I did it in, in another place, not right there in the lineage of my simplification of the expression. All right, so I've got 4 times that x plus 4 times that 3, which simplifies to 4x plus 12, and I'm going to take that and I'm going to put that right underneath, scratch out the work that I did, and bring everything else down. So there we go. Scratch out the 4 times x plus 3, because that became a 4x plus 12. And then I brought down my 2x plus, and then my plus 5 over here, just like that. And now I just have an expression that I can combine like terms. I can combine the 2x and the 4x, and I can combine the 12 and the 5. And my final answer is 6x plus 17. All right, you try this one. All right, so go ahead and try this one. Don't forget, keep change opposite in the beginning. All right, try that one, and then come back and see what the answer is. Okay. All right. Like I said before, we're going to apply first, keep change opposite, and then we're going to go through our order of operations just like that. All right. So the first thing we need to do is change this subtraction to an addition, and that 4 to a negative 4. Change that subtraction to addition, change this to a negative 3. Change that subtraction, turn this to a negative 8. All right, just like that. All right, so you see all we did here is apply keep change opposite. Now don't make the mistake of just turning subtractions to addition. All right, you can't do that. If you turn that to an addition, you're changing the problem unless you make the next number its opposite. All right. The reason why I would do this, and the reason why I do keep change opposite at the very beginning, this is the precise reason. Whenever you have a subtraction in front of a number that's being multiplied by a grouping, you've got to understand that that subtraction makes that next number negative. All right, it influences the next number to be its opposite. Right. So you've got now 3x plus negative 4 times x plus negative 3 plus negative 8. All right. Now then, we're going to come down here in our margin, all right, and our scratch sheet of paper, and we're going to do this negative 4 times x and then negative 4 times 3. All right, we're going to distribute that multiplication all the way across, just like that. We get negative 4x plus negative 4 times 3, which is positive 12, because a negative times a negative is a positive. So we've come up with negative 4x plus 12. All right, that's written right here in the middle, and then we bring everything else down that we didn't touch. Now then, we can add these together. Negative 4 plus positive 3, that's a negative 1x. And if it's a 1, a negative 1, that 1 is invisible in front of the variable. All right? And then you've got 12 plus negative 8. Is there a ward? Yes, the difference is 4, and positive 1 the ward. So our final answer is negative x plus 4. All right. I hope you enjoyed this lesson. All right. As always, if you have any questions, you can write the questions down in the comments down below. Any comments that you want to write, you can do that. Again, great idea to subscribe, and I hope you have a great day.